This lesson is about equivalent fractions. We learned about kind of understanding equivalent fractions and creating them and drawing them and looking at a drawing and renaming them. But of course, like all math, there's a shortcut. So now that we understand what equivalent fractions are and what they look like, we are going to understand how to actually create them and make them. So let's write our title for today. How to make equivalent fractions. Remember, equi means equal. In an earlier example, we learned that 1/4 is the same as 2/8, the same as 4/16. So we've got 1/4 or 2/8 or 4/16. Look at these fractions. We said that they're equivalent, which is why we've got an equal sign in between. Do you notice a pattern? By the way, you do not need to write this down in your how-to book. You already have this written down. So let's take a look at this pattern. Think about multiplying and dividing. Whatever we do to the numerators, we have to do the same thing to the denominators. Otherwise, we're not going to keep the fractions equal. So let's take a look. To get from 1 to 2, we multiplied by 2. Write this down in your how-to books. To get from 4 to 8, we also multiplied by 2. And check it out. To get from 2 to 4, we doubled it again. We doubled the amount of pieces in that brownie pan by cutting every piece in half. So basically multiplied the number of pieces by 2. It's the same amount. I'm not changing the amount of brownies that I got to eat. I'm just renaming it, just giving it a different name, different way of thinking about it. You could also think about going from the 1 all the way to the 4. In order to do that, you multiplied by 4. And in order to get from 4 to 16, you also multiplied by 4. Because whatever you do to the top, numerator, you got to do to the bottom, denominator. So that is one way of making equivalent fractions. Let's look at it differently. Say we were starting with 4/16 and we wanted to rename it into simplest form, 1/2, or reduce it. We could reduce to 2/8, we could reduce to 1/4. Or we could just do that all in one motion to be really, really efficient. So let's take a look at it going the opposite direction. Now the other way we traveled, we used multiplication. Now if we're traveling the opposite way, then we need to use the opposite operation. So what is the opposite of multiplication? Well, that would be division. To go from 4 to 2, you would divide by 2. And whatever you do to the top, it has to be the same rule or pattern for the bottom. Does it work? Yes. 16 divided by 2 is 8. We can keep reducing that and renaming it to go from 2 to 1, divide by 2 again, and to go from 8 to 4, divide by 2 again. What if you wanted to be really, really efficient and do this in just one jump? Could you do that? Is there anything that you could do to get straight from 4 to 1, and it has to still work to get straight from 16 to 4? What do you think? We could divide by 4 and divide by 4 again. So it's really nice when you've got two even numbers. You can divide by 2, divide by 2, divide by 2 until you can't divide anymore. Or you can think, what's the greatest number that I could divide both the top and the bottom by? Because then I get to simplest form in just one step, and it's nice and neat and compact. So let's see if you can create an equivalent fraction. Let's try out if I gave you 3/8. What equivalent fraction could you come up with? Think, whatever I do to the top by multiplying or dividing, I have to do the bottom by multiplying and dividing. It's just multiplication and division here. Well, one thing that you could do would just be to multiply by 2. We can all do our 2's. Three times 2 gets us 6. And 8 times 2 gets us 16. So 6/16 would be an equivalent fraction for 3/8 by using multiplication. Let's try another one. Let's do 3/5. This time, just for fun, let's not multiply by 2. Let's see if it works with multiplying by something else. This time, let's multiply by 3. Why not? Three times 3, 5 times 3, 9/15 is the same as 3/5, or 3/5 is equivalent, there's that equal sign, equivalent to 9/15. Now let's go the other way. Let's show how we can make an equivalent fraction by using division. Let's do 12/15 to start with. Think about how you could divide both the numerator and the denominator by the same thing to get an equivalent fraction. Think about the ways that you can make 12 in terms of factors. 1 times 12, 2 times 6, 3 times 4. And think about the factors that make 15. 1 and 15, 3 and 5. Do they share any factors? Because then you could divide by the same thing. Yes, they do share factors. They share the factor of 3. They share the factor of 3. So we'll divide by 3 and we'll divide by 3. 12 divided by 3, or 12 split into 3 groups, would be 4. 15 divided by 3, or 15 split into 3 groups, would be 5. So our equivalent fraction for 12/15 is 4/5. We could also say that that's a reduced fraction because the numbers got smaller or lesser. And we could say that this fraction is in simplest form because you can't reduce it or divide it down anymore. Let's say that you had a problem like this. Is 3 inches the same as, we don't know, 6/16? Is it the same? Is it equivalent? Well, in order to be equivalent, we would have to do the same multiplying, dividing to the numerator and the denominator. Keep the pattern the same. Is there a pattern that'll work? Why, yes, there is. Think, 3 times what gets you 6? Well, that would be times 2. 8 times what gets 16? Well, that's times 2 also. So, yes, they are equivalent fractions. What about 4/10 and 3/5? Are these equivalent fractions? If they are, we'd have to be able to do the same multiplying and dividing to the numerators and the denominators. Now let's start with the denominator this time. So to get from 10 to 5, we divided by 2. That would mean that we'd have to also divide by 2 to get from 4 to 3. 4 divided by 2 is 3? Uh-oh, we've got a problem. That's not correct. 4 divided by 2 is not 3, it's 2. So this should be a 2 if these were equivalent fractions. So, since 4 divided by 2 is not 3, that means that these are not equivalent. The professional math way of writing that is with an equal sign with a diagonal dash through it. There we go. 4/10 is not equal to 3/5. Okay, time for some algebra. Let's do this. Find the missing denominator. If we have a statement that 15/24 is equivalent to 5 somethings, how could we find that missing denominator? Well, let's use our pattern to find out. If this is really an equivalent fraction, we'll be able to do the same thing to the numerator and the denominator. So, let's try it out. We can't start down here because we don't know what we're trying to get to. So we should start up here because we have enough to work with. 15 to 5. Is it multiplying or dividing? Well, it's dividing because we're getting smaller. 15 divided by what is 5? You can think of it backwards, though. You can think 5 times what gets you 15? And our answer would be 3, either way. That means we can do the same thing to the bottom. 12 divided by 3 is what? Or, if division doesn't come naturally for you yet, think of it this way. What times 3 will get you to 24? Or 3 times what is 24? That's going to be our missing denominator. Have you figured it out yet? Our missing denominator is 8. Okay, that is it for homework for tonight. It was a lot of information for finding equivalent fractions. If you still think that it's kind of tricky, give yourself a couple of examples and give yourself a test run tonight in your how-to book. Tomorrow, you are going to have some problems to solve in your discussion group, so you need to make sure that you understand how to get an equivalent fraction or how to find a missing denominator. Tomorrow, we're going to be talking about equivalent fractions and how they relate to basketball games, how they relate to clocks, and how they might relate to surveys. So be ready to do some problem solving and some real-world examples with equivalent fractions tomorrow.